Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is a continuation of a series of videos on identities in trigonometry. We have already covered the sum and difference of angles identities for the sine, the cosine, and subsequently the tangent, and the double angle identities, again, for sine and cosine and subsequently the tangent. We've also talked briefly about the power reduction formulas, and those are highly related to the half angle identities that we're going to do here. And in fact, I find the half angle identities are much more important. So of the two, between the power reduction and half angle identities, I highly recommend you get to really know the half angle identities, because if you square them, they are the power reduction formulas. So here are the the half angle identities right here. By the way, this video is dedicated to the proof, the theorem and the proof of the half angle identities. The half angle identities are as follows. The sine of an angle over 2, basically half an angle, the sine of half of an angle, alpha over 2, is plus or minus the square root of 1 minus the cosine of the regular angle all over 2. Very important to notice here, that 2 is, which is in the denominator, is under the square root as well. A lot of students miswrite this and they write that 2 outside of the radical. That 2 is in the denominator and it's in the radical. It's part of the radicand. So just to let you know, that's something that I find a lot of students make mistakes on. Notice there's that's a plus or minus in front. We'll discuss why that's there in a moment. The cosine of the half angle, that's also plus or minus the square root of 1 plus the cosine of alpha over 2. And then there is a tangent of half angle formula. In fact, there's 2 of them, but I don't require my students to memorize those. Your instructor might require you to memorize those. I just think they're silly to memorize the tangent identities. The plus or minus sign, we'll talk more about that in a moment, but part of the theorem just says that plus or minus sign that's in front of the radical is determined by which quadrant your half angle terminates. So, or which quadrant your half angle terminates in. So let's go ahead and start with the proof, and then I'll go back through and talk about that plus or minus square root. Well, we know from the power reduction formulas, or better yet, maybe I should start this with just the basic double angle formulas. We know that the cosine of twice the angle theta is equal to 2 cosine squared of theta minus 1. So this actually is the double angle formula, but you could read this slightly differently. You could say, well, if I have an angle, then sorry, I'm kind of pausing a moment here. If I have an angle, a single angle here, the cosine of the double angle is related by the cosine of double angle being twice cosine squared of the single angle minus 1. But there's a better way to kind of think of this. Cosine of an angle is equal to twice the cosine squared of half of that angle minus 1. That is, you could have written this formula as follows. Cosine of an angle is equal to twice the cosine squared of half of that angle minus 1. It's saying the same thing, right? In the first case, the highlighted case, we're calling that angle 2 theta, and notice we're taking the cosine squared of half of that angle, theta. In the second case, we're saying we have an angle alpha, and on the right hand side, we have the cosine squared of half of that angle, alpha over 2. It's the same statement, it's just they're written slightly differently. So if this was, for example, 60 degrees, this would be 30. Well, if this was 60 degrees, this would be 30. It's the same statement, right? So that's why I'm just saying these are saying the same thing, but the second form here is very useful because if you add 1 to both sides, you get 1 plus the cosine of alpha is equal to 2 cosine squared of alpha over 2. And then you could divide both sides by 2. So you have 1 plus cosine of alpha, and that's being divided by 2, is equal to cosine squared of alpha over 2. And recall from your algebra course, if you have something squared is equal to a number, you could take the square root of both sides and you get a plus or minus. And this is where that plus or minus comes from, is you have a cosine squared equaling some number on the left hand side. So when you take the square root of both sides, you will get that plus or minus. You get plus or minus the square root of 1 plus the cosine of alpha, and that's over 2. Remember that 2 is within the radical, and that's going to be the cosine of the half angle. And note, that is actually the proof of this guy right here. And a similar argument would showcase the proof of the sine of the half angle. I think I'll just do it anyway. So to get the sine of the half angle formula, recall cosine of the double angle again is written, another optional way of writing is 1 minus twice the sine squared of the regular angle. Notice here is twice the angle and there is the regular angle, or in other words, this is an angle and this is half of that angle. So I could write this as cosine of angle is equal to 1 minus twice the sine squared of half of that angle. They're saying the same thing. But in this case, the second case, I could solve for sine squared. I'm going to add 2 sine squared to both sides. 2 sine squared of alpha over 2 is equal to 1. And then I'm going to subtract the cosine of alpha from both sides. Now I'll divide both sides by 2. So notice this is pretty much how we derive the power reduction formula, but it has a little more oomph to it when you do it this way, because not only do I get the power reduction formula right here, but I'll get the half angle formula by taking the square root of both sides. Oops. Taking the square root means I don't have that square anymore. And so we have sine of alpha over 2. But when you take the square root, you get a plus or minus square root of 1 minus the cosine of alpha being divided by 2. Now, I remember when I was a student, I had a hard time remembering how these formulas worked. Like, I knew they both involved cosine, but I couldn't remember pluses or minuses. So here's the deal. The sine and the cosine will be of opposite signs. So if this is a sine, that is going to be a negative cosine. But the cosine, on the other hand, likes itself. So the cosine will give me a positive cosine. That's kind of the way I would think about it. So cosine gives me positive cosine of the half angle, that is, gives me a positive cosine in that radical. And the sine of the half angle gives me a negative cosine. There you go. So that is, those are the proofs of the half angle formulas for the sine and the cosine. Now let's talk a little bit about the plus or minus that were the sine, SIGN signs, the plus or minus SIGN signs. So if I give you an angle, let's say I say alpha itself was, let's just pretend it was 210 degrees. Okay. Well, half of 210 is 105, right? So if alpha is 210, we're actually looking at the sine of 105 degrees when we're looking at the half angle, or half of 210. And 105 is in quadrant 2. And I know, therefore, that sine would be positive. And that's how I would do this, is every time you deal with a half angle formula, first of all, you have to be given the regular angle. Well, you don't have to, but in general, you are given the regular angle. You'll take half of that. You'll determine what quadrant that half angle is in, and then use the fact that if it's in quadrant 2, sine is positive. So you know your answer is going to be positive in quadrant 2. If your half angle was in quadrant 3, for example, well, sine is negative in quadrant 3. And so therefore I would not keep the positive. I would keep the negative. We'll see this in examples, but that's the idea. That's how we're going to tackle these styles of problems. But I just want to give you kind of a heads up before we continue forward. That's how that's going to go.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.